Okay, so the next thing that we want to do is I want to place, and so there's a useful tool when you have a curve or you understand that as a path, is a way to place planes on kind of normal to that path, perpendicular to that path. And it's not called a plane, but it's basically a plane. It's the same thing. It's called a frame within here. And so this tool is called, let's type frame and see what comes up. Curve frame. We actually want perpendicular frames, and we can see the little icon there. There's a line, that black line that's drawn, and then these frames that are sitting perpendicular to it. So perpendicular frames allows us to do a couple of things. Let's connect our curve. Now we can see a series of planes have been constructed on that here at the beginning. Here's the next one. And so these are moving. We can change the count and we can change the alignment. And so for count, this is going to be independent. It doesn't have to be tied to the number of divisions. It could be. We could pull that same parameter, that same slider. For this, let's set each plane is going to be the address or the location of an object. And so let's set this, I don't know, 10, 30, 10 is less than 30 is less than 100. We'll set that count. And then I'm not sure, I didn't play with this before. This is a Boolean variable. Let's see, true or false. In this case, well, we can play with this. We'll see what happens with this later. But basically what's happening is that we have a perpendicular plane or frame set on our curve and equally dividing. So if we increase this, we're going to increase those numbers of frames. If we decrease it, obviously we're decreasing those. But we always have one at the beginning and we always have one at the end. So it's just a simple division. There's a little bit of weird things that are happening. What I'm doing is looking at the red and green axes on that frame. Some of these are pointing up. Some of them are pointing down. Let's see if we just set the alignment. Now some are pointing in and some are pointing down. Let me just look at one more thing. So that didn't change anything either. So I looked at this before, and there's a way that we will be able to manipulate this in a second. So let's take our let's see. What we want to do now is use a tool called Orient. And so this Orient tool will allow us to take geometry and begin to map it three-dimensionally. And so what we're going to do is we're going to draw something on this plane at the bottom, and we can do this simply in Rhino. Use the green and the red axis and that point as a reference to then map it to these planes. So let's try this. Let's do Orient. And so we're going to take geometry. And so let's just try this with something very simple. Let's start with a circle here. And let me make it, let's see, we'll do surface. I just want to do planar curve. And ghosted. So now we have that just simple circle. Circle may not, we'll see this in a second, the circle may not be great because of its orientation, but let's set a container for brep. And we'll set one brep to be that planar surface, and we'll plug that into geometry. And so what we're going to do is we're going to use the source, and that source is the initial plane. That plane is what we have as our XY plane all the way back at the beginning. So pull and we'll drag that over to the source. And then our target will be our frames. If we zoom out, now what we see are those points, or that planar surface or circle mapped to each one of those points on our helix. So we can hide our frames. We can even hide our interpolated curve. And now we get those points in space, or those circle panels in space. So that could be interesting, but what I really want to do is to go back to what I showed you is some way, like Alto's cabin, building up geometry using some objects. And we're not going to be super precise about this because they're not stacked on top of one another. We're not really getting object to object matching, but we want to begin to approximate a space. And so what we can see here is that when we map our disk flat to the plane, that's perpendicular to our curve. And so what that tells me is that I can begin to play with other objects on here. And let's create, let's say, a rectangle. I don't know, 2 feet by 1 foot. And maybe I'll move this. I'll delete my delete the circle and delete that disk. You can see they all went away because our brep. Let's make another planar. Actually, let's extrude solid, extrude planar curve straight. Just a simple rectangle. Let's see what happens when we set this brep to that solid object. So now we just got a collection of objects in space. And what's nice is that we can map. I keep using the word map, but what we can do is now calibrate our objects based on this one object. So if we want to scale it, we know it's starting at that 0 point and going up. So let's see what happens if we scale this and scale 1D. And change its height. Those objects now just extended out beyond our helix curve here. If we want to move them down, we could do that. Maybe I'll go to the front view. Now we can see the way that they're beginning to approximate that space. Remember, we've got our unit Z, so we can always increase these or decrease these. We could probably even map. You could play with mapping the height of your step here and match it. So you could, this B rep need not to be a kind of simple geometry that we just draw in Rhino. That could also be tied to our variables, right? And so if we lower this down, we can start to produce some other things. But maybe it's, and here's where we can really just start playing with something. Maybe we want to scale 1D. This object, maybe it was too long. Maybe we want to scale 1D this way. Or we could undo it and we could scale 1D in that direction. And you can just move back and forth between your steps and your objects. And so what I did is I started with the simplest of objects. But let's, and what we can also do is start to get a sense of which way is the green line. So let's go back to our perpendicular frames. We can turn those on. Can we start to get a sense for that? Let me delete this. So it seems like our red frames, they may be changing slightly, but let's just keep this as a frame of reference. Okay, I'll undo that for a second. We know that the height is one of these. We know that this in terms of its kind of axis perpendicular to the frame is its overall length. So what if we just looked in these two views? We can see one is solid, or one is wide. So this is the length as it gets rotated. This is the kind of face of it. And maybe what I'll do is I'll just draw a more complex shape. More of a kind of scale. Oh, I do want to close it. But I also want this to be asymmetrical. And then let's extrude it a little bit. We'll do this as a solid. Extrude planar curve straight. Doesn't have to be too thick. We'll take both of these, we'll move it over. And we'll make sure that it's centered over the point. And now let's set this to be the B rep. So we can see it's starting to rotate or kind of flip around. And let's see if that has to do with this align. All right, so now it just turned into more of a rose. And this is what I was expecting, actually. And so what we can do is to add one last rotation to each of these oriented objects. And we can rotate them based on the plane of the frames. And we can set a kind of range from one value to another value. And it looks like what's happening is it's basically going from 0 to 180. And so we can play with that range. Let's set a rotation, because I want to imagine all of these as more kind of facade panels. So let's rotate the oriented objects. We'll leave the angle, we'll set that to be a degree. Let's set the plane to be the frames. We can hide our oriented objects, and nothing's changed yet. But let's set a range now, because it looks like we want to go from some version of rotating something 90 degrees to not rotating it at all. And so let's set our domain. So let's see, range. Well, let's leave this alone for a second. Range. So our number of steps are actually going to be our number of objects. And our domain, we'll do a construct linear domain. And let's set this to be, let's try 90. Because I want to, those that are flat on the bottom, I want to flip those up. So maybe that's 90. And then the domain end, let's set that to actually be 0. I don't know if this will work. We'll set that to be the domain. We'll set that to be the angle. All right, so something else is starting to happen there. Which is kind of cool. And so what you might look at is just how you begin to manipulate some of those. It looks like it's changing in the middle. And so we could even set, let's set 0 is less than 360 for the start. And we'll copy this. And this will allow us to at least manipulate and see if it's just one linear change. Through these. So that allows us to set where we're starting in terms of that rotation and where it ends. And so these two will allow us to kind of tune this. We can see the way that the shape, the overall shape is starting to change. There's also a lot of overlap between our oriented objects. And so if I want to kind of elevate those a little bit more, I can change that step size. But we can see as I do that, they're also beginning to flip and change that way. So now we can kind of tune this by coming back and setting that rotation. So we're starting to get a layered object through a series of parts there. We can also, if there's too many parts, we can also turn this down. Let's say our part was too big. We'll get to the point where maybe we get a little bit of transparency through that. And in this case, all of these different parameters will affect the overall form. So we can see as we create more height, we might have to change that rotation. But what I'd like you to do now is to just play with that object. So the kind of panel that we're going to make. And I can hide that here so that we don't see it. We can come back, we can hide the B rep here so that we don't see that. And at this point now we can also hide our first plane and our first point. So we just have this object that we're working with. And the last thing, if you wanted to play a little bit with creating a kind of family of these, if you really, really love one of these, you should probably make a note of what the parameters are. But if you want to just kind of begin to capture them and move them off to the side, we can go from our rotation here and we can simply bake this. And when we bake it, let's make sure that we bake it as a grouped object. And we can move this over. This will freeze that geometry. And we can come back and we can manipulate any of these parameters. We can change our the B rep that we're working with. And so what's nice about this setup is that it gives us quite a few different parameters to be working with. And then we could bake this and pull that off to the side. Just be sure to keep grouping them given the number of objects that we're working with here. And then we can change our view to rendered. We can get a better sense about what that might look like in terms of shadow and in terms of the kind of overlapping of these things. And again, this is intended right at an early stage where we want to just look at a kind of early ideation of an aggregated number of parts. These parts, and we'll get to this later in the semester, these parts don't understand where they are in relationship to one another. We're not detecting clashes between objects or anything like that. We're just simply taking these objects and beginning to approximate a form. And also in this case, the form that we used was just a simple helix. Simple, maybe not so simple given the number of steps that we had to build that, but that could be any form that we start to use in terms of contouring something, working with another geometry, and however you want to build that up. This was just simply an example of working to show you an example of building up a kind of path, taking that path, manipulating the data as a way to work with it, and then also introducing this idea of the perpendicular frames and orienting objects to be mapped from one starting position to those kind of points in space based on those frames. So my hope is that you can use this as a way to want to understand these key concepts, but that it might become immediately deployable in your studio projects, just as a simple way to begin to approximate something. And we're also starting to get to this place where with a simple, and I would say relatively simple Grasshopper set of components allows you to create much more richness or complexity in form than you would be able to get if you were just simply stacking up parts in a kind of very simple one-to-one analog way of building something digitally. So I hope this helps. As always, let me know if you have any questions, and we'll continue to unpack this a little bit during the class and be able to talk about the concepts and help you understand these things more deeply. Thanks for paying attention.